Good evening, students. Welcome to the lecture number 4. This lecture is in continuation of the lecture number 3. In the lecture number 3, we have studied about the zero error, and we have also solved a couple of questions in which we have tried to understand how we can calculate the linear dimensions of any object with the help of Vernier Caliper. Now, in the today's session, we will be studying about the zero error, and we will also try to solve a couple of questions on zero error, and apart from that, we will also take up a couple of questions from the screw gauge. In the case of screw gauge, we will try to solve the simple problems in which we will try to find the pitch and the least count of the screw gauge, and then we will also take up one question in which the concept of zero error will imply. So let us start with these two questions which I have written on this board. In the first question, we have to find the zero error. Now, just I want to revise the definition of zero error. Zero error occurs when zero error occurs in any instrument when the zero of the main scale doesn't coincide with the zero of the Vernier scale, and the zero of the Vernier scale is either on the left hand side or on the right hand side of the zero of the main scale. This definition is in particular related to the Vernier caliper. In the Vernier caliper, if the main scale zero is not coinciding with the zero of the Vernier scale, then we say that that particular instrument has got a zero error. Zero error arises due to prolonged usage and or when the instrument is not calibrated for quite a long time. So now in this case, here you can see here that the zero, this is the zero of the Vernier scale. The zero of the Vernier scale is not coinciding with the zero of the main scale. So there is a zero error. Now, zero error are of two types. One is a positive zero error and one is a negative zero error. In the case of a positive zero error, the zero of the Vernier scale is on the right side of the zero of the main scale. And in the case of negative zero error, the zero of the Vernier scale is on the left side of the zero of the main scale. So in this case, you will see that the zero of the Vernier scale is on the right side. It is on the right side of the main scale, so it is a positive zero error. In the case of positive zero error, we have to apply the negative zero correction in the final measured value. So here in this question, we have to only find the zero error. So zero error is equal to zero error. The formula for zero error is equal to the least count of the measuring instrument into the coinciding Vernier scale reading. Coinciding Vernier scale reading means that division of the Vernier scale which is coinciding with the main scale division. So here you will find that the third division of the Vernier scale is coinciding with the main scale division. So the zero error is equal to LC into the coinciding Vernier scale reading, which is equal to 3 here. LC of this instrument is the LC, that is the least count of the Vernier caliper, is equal to, you know, the LC is equal to 1 main scale division divided by the total number of divisions of the Vernier scale. Now here you will say, you will see that the total divisions on the Vernier scale are 1, 2, 3, 4, 5, 6, 7, 8, 9, there are 10 divisions. The value of one main scale division is equal to how much? It will be, see, from here to here it is 1 centimeter, and this 1 centimeter is divided into 10 equal parts. So the value of one division will be equal to 1 by 10 centimeter, which is equal to 0.1 mm, sorry, which is equal to 1 mm, or we can say the least count is equal to 0.1 mm. Okay, so we will put this value here. So least count is equal to 0.1 into 3, which is equal to 0.3. Now, since this is a positive zero error, so the correction which will be applied in the measurement of any linear dimension of any object will be negative. That is, if for example, if you have, let us say, the measured the diameter of any let's say circular wire, that is, let us say it is equal to 2.8 mm. This is the final reading which we have got by that this instrument. So what will be the actual value? The actual value will be equal to, the actual value will be 2.8, which has been measured by this instrument, minus 0.3. So the actual value will be equal to 2.5 mm. This is 2.8 is the measured value, that is 2.8 mm is the measured value of any this circular wire, and zero error is 0.3. This is a positive zero error. So when there is a positive zero error, we will apply a negative zero correction. So I have, what I have done is I have just minus this value from 2.8. So we are getting the final answer as 2.5 mm. So in this case, the zero error is equal to 0.3, and the zero correction, if I am just talking about the zero correction will be equal to minus 0.3 mm. Okay, zero error is equal to 0.3, and the zero correction will be equal to minus 0.3. So this is the first question. The second question is, I will just now rub it down. In the second question it is written, when the jaws of a Vernier caliper are closed, जब आपके लोअर जॉज हैं हमने उसको आपस में बिल्कुल टच करा दिया, तब the zeroth division of the vernier scale is to the right of the zero of the main scale. इसका मतलब क्या हुआ कि zero error is positive. पहली चीज तो आपको क्लियर हो गई. अब अगर zero error पॉजिटिव है तो zero correction नेगेटिव हो जाएगा. It implies that zero correction is negative. ठीक है. Now sixth division on the Vernier scale coincides with the main scale division. Find the correction to be made in the measurement. So answer यहाँ पे 4 यहाँ पे alternatives दिए हुए हैं, और the least count of the instrument is 0.1. So correction हमें निकालना है, that is they are asking about the zero correction. So zero correction is equal to least count into the coinciding Vernier scale reading. Okay. So the least count is given as 0.1. Now here see, since it is since the zero division of the Vernier scale is on the right side of the zero, the main scale, so it is a zero error is positive and the zero correction is negative. So I will just write it as negative. Least count is 0.1 into coinciding Vernier scale reading कितनी है? That is the sixth division. The sixth division is coinciding with the main scale division, so I will write it here as 6. So the answer will be equal to minus 0.6 mm. So the zero correction which has to be applied in the observed or in the measured value, that will be equal to minus 0.6 mm. The third alternative is correct. Okay. Now I will take up a couple of questions on the screw gauge. These questions will be very simple, where we will try to first of all find the least count of a screw gauge and the pitch of the screw gauge. So that let's do one question. It's a very simple question. Find the least count of screw gauge. Find whose head scale is divided into 200 divisions, is divided into 200 divisions, and the spindle moves 5 mm when the head scale is rotated through 5 revolutions, and the spindle moves 5 mm in 5 complete rotation of the head scale, in 5 complete rotation of the head scale. See, head scale is the circular scale, and here we have to find the least count of the screw gauge, whose head scale is divided into 200 divisions, and the spindle moves 5 mm in 5 complete rotation of the head scale. Now what is the pitch? You have to first of all find the pitch. Pitch is equal to the distance travelled by the spindle in 1 revolution. So here the spindle has moved 5 mm in 5 complete revolution. So 5 mm in 5 complete revolution. So the pitch is equal to 1 mm. That is, this is the distance moved by the spindle of the screw gauge in 1 rotation. So the pitch will be equal to 1 mm. Now, least count of the screw gauge is equal to the value of pitch divided by the total number of division of the circular scale. Total number of divisions on the circular scale or the head scale. Here they have written this as the head scale. Head scale and the circular scale are the same thing. So the pitch is equal to 1 mm. We have write it down as 1, and the total number of divisions is equal to 200. Okay, now here in this question they have given 4 alternatives. Yeah, the 4 alternatives are: first alternative is 5 into 10 raised to the power minus 4 centimeter. B is 5 into 10 raised to the power 4 minus 3 centimeter. C, 5 into 10 raised to the power 4 centimeter, and D is 5 into 10 raised to the power minus 2 centimeter. So these are the 4 alternatives which we have in this question, and we have to find the correct alternative. So our least count is equal to 1 by 200 mm. or we can write it down as 1 by 2 into 1 by 100 mm. I have just this is equal to 1 by 2 into 1 by 100. That it's very easy. So 1 by 2 into 10 raised to the power minus 2 mm, which can also be written as, because now we have to write down this measurement in terms of centimeters. So what I will do is 1 by 2 is equal to 0.5 into 10 raised to the power minus 2 mm, which is equal to 0.5 into 10 raised to the power minus 2, and 1 mm is equal to how much? 1 by into 1 by 10 centimeter. Okay, 10 mm is equal to 1 centimeter, so 1 mm is equal to 1 by 10. So we are getting this value is 0.5 into 10 raised to the, now this 10 will go up, so it will become minus 3 centimeter. Now 5 can be written as 5 by 10 into 10 raised to the power minus 3 centimeter. So this 10 will go up and we will get the answer as 5 as into 10 raised to the power minus 4 centimeter. So the correct answer here is the correct answer is the alternative A, or the first alternative. Okay, so this is how we find the least count of the screw gauge. So here what was important for us, that we have to find the pitch also. After finding the pitch, we can easily find the least count of this instrument. So the answer is 5 into 10 raised to the power minus 4 centimeter. The correct alternative is A. Now let us move on to the next question, which is going to be again from the screw gauge. The question is, in a screw gauge, the anvil and the spindle are touching each other. Question is, when the anvil and the spindle of a screw gauge are touching each other, the zero mark on the thimble scale, the zero mark on the thimble scale zero mark on the thimble scale is beyond the zero mark of the main scale, is beyond the zero mark on the main scale. At this moment, the 55th division in the thimble scale matches the datum line. At this moment, 55th division on the thimble scale matches the datum line. There are 100 divisions on the thimble scale. There are 100 divisions on the thimble scale, and and the screw advances 1 mm in one rotation of the screw cap, and the screw advances 1 mm in one rotation of the screw cap. The diameter of the rod measured with the screw, a rod of diameter D is measured with this screw. Rod measured with this screw shows 5 in the main scale reading. Rod measured with this screw shows 5 mm on the main scale reading and 12 on the thimble scale. What is the value of D? The dia of the rod. The dia of the rod measured with this screw shows 5 mm on the main scale and 12 on the thimble scale. Now here the thimble scale is the circular scale and this main scale is the pitch scale. Okay, main scale is the pitch scale and the thimble scale is the circular scale. Anvil and spindle. Whenever we are moving the ratchet, which is provided in the screw gauge, when we move the ratchet, the spindle moves forward, and there is a U frame in the this screw gauge. So at one side of the U frame you will find a small stud which is called the anvil. So the object whose linear dimension is to be measured is inserted between this spindle and the anvil, and when we move the ratchet, this spindle moves forward and it comes in as and when it comes in contact with the outer surface of that object, the ratchet will become free. So at that moment of time you have to measure the diameter or the linear dimension of any object. So here he is saying that the anvil and the speed and the spindle of the screw gauge are touching each other. It means that at that point of time the zero mark on the thimble scale is beyond the zero mark on the main scale. Now let us see, I am just trying to make you understand this with the help of a very simple diagram. This is the pitch scale reading, and this is the circular scale, and this is the pitch scale. Now here let us say the zero mark on the pitch scale is here, and this is the circular scale. So इसमें बहुत सारे divisions हो जाएंगे. Let us say like this, maybe. Now here he says that a zero mark on the thimble scale or the circular scale is beyond the zero mark on the main scale. Beyond means that this zero is you can say that this zero will be somewhere here or here, but it will be on the downside. Okay, so here let us say this is the zero mark on the circular scale, so it is on the downside. So at this moment the 55th division on the circular scale matches the datum line. Datum line means the 55th division of the circular scale is matching the pitch scale division. Okay, any division on the pitch scale. Now when the zero of the circular scale is beyond the zero mark on this main scale or the pitch scale, then the zero error is positive. Here the zero error is positive. That is when the 0 on the circular scale is on the downside with reference to the 0 on the pitch scale, then in that case the 0 error is positive. If the 0 was on the upside of this 0 mark, let's say if the 0 was here somewhere, let us say here, then it is on the upside of the 0 on the pitch scale. So in that case the 0 error will be negative. So here in this case the 0 error is positive, and when it is positive, so 0 correction will be negative. 0 correction is negative. Okay, now we have to find the diameter of the rod. So diameter of the rod क्या होगा? In the case dia will be equal to, that is the pitch scale reading plus circular scale reading into the least count minus 0 correction. 0 correction is minus because the 0 error is positive. Now this is now here you say that the 55th division on the thumble scale matches the datum line. Okay, so there are 100 divisions on the thimble scale, and the screw advances 1 mm in one rotation. The screw advances 1 mm in one rotation means pitch is equal to 1 mm. There are 100 divisions on the thimble scale, means on the circular scale. So least count is equal to pitch divided by the total number of divisions on the thimble or the circular scale, which is equal to 1 divided by 100, which is equal to 0.01 mm. LCM ने निकाल दिया. अब हमें 0 करेक्शन निकालना है. 0 करेक्शन के लिए हमें क्या करना है? 0 करेक्शन के लिए हमें LC की वैल्यू हमें पता है, and when the anvil and the spindle are touching each other, then 55th division on the circular scale is matching the division on the this pitch scale or the main scale. So 0 correction is equal to LC. LC is equal to 0.01 into 55, and this will be minus because the error 0 error is positive, so it will be equal to 0.55 mm. So we have found this value also. Now we have to find the diameter, the true value of the diameter with the help of this instrument. So here it is written that when we are measuring the diameter with this screw gauge, it shows 5 mm on the main scale reading or the pitch scale reading, that is equal to 5 mm, plus circular scale reading is how much, and that is the 12th division on the thimble scale or the circular scale. This is the 12th division on the circular scale or the thimble scale, which is coinciding with the one of the divisions on the pitch scale or the main scale. So we will write here as 12. LC is equal to 0.01 minus 0.5. So the answer is 5 plus 12 into 0.01 is equal to 0.12 minus 0.55. 5.12 minus 0.55. So the answer is, let me check the answer also here. I think so here if we will minus, there are 4 options given here. That is one is 4.57. How much for 4.57 mm? B is 5.12 mm. C is 4.58 mm, and D is 5.24 mm. ठीक है. सो हमारा क्या आंसर आया? 5.12 माइनस 0.55. 5.12 0.55, so which is equal to 7. This is equal to 5, and yeah, so our answer is equal, this is equal to 4.57 mm. Okay, so the correct alternative is A, that is 4.57 mm. So this is the correct diameter of the rod as measured by this screw gauge, and I hope you must have understood this question, and you must have understood the way I have solved it also. So today we have discussed about the zero error. We have also tried to solve 4 questions on how to find the dimensions of any physical object with the help of the screw gauge and the vernier gauge, which are having a zero error. So in the next session, I will be now taking up the next topic of errors in measurement, and that will be the lecture number 5. And before ending this lecture, I have to make an announcement from our side that we are going to start a crash course from the month of October for the students who are preparing for the board examinations, that is the 12th board examination, the NEET and the JEE mains at our center in sector 87, Faridabad. So the enrollment will start in the first week of October, and probably the classes will be starting from the 3rd week of October. The crash course duration will be of 90 days, and probably we will be ending the entire course by 15th of January. So whosoever is interested can contact us on my mobile number also, and can enroll for our courses as soon as possible. The enrollment will start from 1st of October. So thank you very much, and I hope that you were able to understand the questions which we have done today, and we will meet very, very soon in the lecture number 5, which will be based on the topic of errors in measurement. So thank you very much. Have a nice day.